All right, 4.7, triangles in the coordinate plane. Um, what we're going to be doing, coordinate proof. We're going to be doing coordinate proofs today, where we're going to take an object that might not necessarily have a dimension. In our last example today, we're going to get to where we're going to keep the lengths unknown, but we'll place the object into a coordinate plane, and we can show things with like the distance formula, the slope formulas, and midpoint formulas that the object, we can find lengths in general and prove things. It's actually a really powerful technique, and you can solve some pretty difficult questions like using the coordinate proof. Our first example is just kind of a warm up. Place a 4x7 unit rectangle in the coordinate plane. So we want to choose a place that's going to make it easy. If I just throw it on here, is this a good place for a rectangle? Well, I look at this when we are going to be using something in coordinate plane, I'm going to be asking like, what's this coordinate? If I want to find the distance of this segment, I'm going to be using the distance formula, and this coordinate is not very useful. So what I'm going to do is I'm going to put it somewhere where it is useful. So it'd be a little bit more useful if I find the, if I place it right on some lattice points, okay? Where these blue lines intersect is called a lattice point. This is a little bit more useful, but finding, this distance not bad and that distance is not bad, but if I wanted to find a slope or something from here to here, or the distance between these 2 points, it's going to be a little bit better if I use the origin as one of my points. Okay, so I should have really chosen a different color for this rectangle so you could see it better, but if I pick the origin as one of the points, I could then label these points in general. Right now it's a 4x7 rectangle, so this is the point. X is 7, Y is 0. This is the point. X is 7, Y is 4. This is the point. X is 0, Y is 4. And this is a point 0, 0. Now, in general, if I just said a unit that a triangle that was, instead of 4 units, let's call it let's call it A units by B units. So we don't exactly know the length, but it's A units by B units. I could call this then B0. This would be BA. This would be B. Excuse me. X here is still 0, right? Y is 0. So notice when you place it on an axis and like the origin, this point still stays 0, 0. It's going to make finding slopes and distances a lot easier when you have a point that doesn't have variables in it. The more variables like BA, the harder it is to work with. B0 is not going to be too bad. All right, so we're going to put a right triangle that has legs of 6 and 8 onto the coordinate plane. And I'm going to do it in a way to make it easiest to find the height of the hypotenuse. So I'm going to place it using the origin as one point. It's really nice. I'm going to actually I could put it over here, but just to be different, I'm going to go over 6, 2, 4, 6, and up 8, 2, 4, 6, 8. I'm going to place it right back here. And for practice, these are set up to be a right triangle, so that makes good sense to put it there. This point would be I went backward 6. I didn't go up at all. This point is I went up 8. So I could use the Pythagorean theorem right away. This is the length of 6. That's the length of 8. Use the Pythagorean theorem to find that length. But for practice, I'm going to use the distance formula. Right? That distance formula is that x2 minus x1 squared plus y2 minus y1 squared. Okay? Remember, x2 is my x coordinate, so I gotta subtract my x coordinate. So negative 6 minus 0. So notice putting it on the axes, negative 6 minus 0 is a pretty easy problem. And y2, 8 minus 0 squared. And notice inside here I get 6 squared plus 8 squared, which is 36 plus 64, which is 100, which equals 10. The hypotenuse is 10 units. Now I want to, using the midpoint formula, I want to show that triangle ABO is congruent to triangle CBO. So what I'm going to do first is I'm going to find the coordinates of the midpoint. What are the coordinates of B? Now remember, the midpoint formula is x2 plus x1 divided by 2 and y2 plus y1 divided by 2. It's the average of your x coordinates and the average of your y coordinates. So in this case, my x coordinates, this is wrong. This should be a 0. No, that one's the right one. Let me undo that. Hey, this is 0, that's 10. Sorry. If this is 0 and that's 10, the average of those, 0 plus 10 divided by 2, you're going to get 5. And the other one is going to be 10 plus 0 divided by 2. I'm going to get 5. So the coordinates of my midpoint are 5, 5. And now how am I going to show this triangle congruent? Well, good question. So we draw in this line here, and the length of this line is 10 units. From 0 to 10 is a length of 10. Length of this line is 10 units. This line is congruent to itself by the reflexive property. So right now I have a side, congruent to a side and a side. All we need to show is our third sides are congruent, and these triangles would be congruent by side-side congruence postulate. So to find that third side, you get your choice. I'm going to use the Pythagorean theorem. This side length is 5, this side length is 5. We're using that midpoint, right? It's 5 units up, it's 5 units still to 10. And this is 5, and this is 5. So 5 squared plus 5 squared, we get the square root of 50. And this is going to be the same legs on this right triangle. So that's how I showed it. These triangles are congruent by side congruence postulate. Okay, using the reflexive property and using coordinates to find distances showing the sides are the same. Okay, so this is not a formal proof, but I showed it. I think we'll skip over this one to get to the last proof here, or one, where we got a true coordinate proof. We want to find the coordinates of P. We want to know what P is. And so for some rectangle, I kind of talked about this on the first example, this length here is a length of from 0 to h is a length of h, right? If this was a 5, from 0 to 5 would be a length of 5. Well, it's a length of h. You're going up from 0 to k. My y values, right? 0 to k, it's k. So the lengths of the sides of this rectangle are hk. So I'm at h, I'm going up. So my x coordinate's going to stay h. My y coordinate's going to be k. So that's the coordinates of P. So the coordinates of P are hk. And now you can do interesting things. You could find the slope of this line if we wanted to. We're staying pretty basic here today, but it's nice to see a basic thing before later on we'll get into more complicated proofs with the coordinate plane. So here's your homework assignment. See you in class.